Hi friends, in this video let us learn about N-channel depletion MOSFET. Right, so whenever we learn about depletion MOSFET, we should know something. What is that? Is in depletion MOSFET, the channel is present from the initial stage, right? So channel is present initially, or channel is available, right? So that is the one thing we have to remember, right? So how channel is formed in the depletion MOSFET? It is formed by doping between source and drain, right? So it is formed by doping between source and drain. So this is very important point with respect to depletion MOSFET. And second thing we have to know is channel is N type. So this channel is N type. That is channel the current flow is due to the electrons. So N type because the current flow in channel is due to electrons. That's why it is called N type channel. So and for N channel MOSFET, substrate or body is P type. We know substrate provides support to the MOSFET structure, so the body is P type here, right? So these are all the points we have to remember, right? Whenever we are working with the N-channel depletion MOSFET. So let me draw the diagram for N-channel depletion MOSFET, right? Here we know this is substrate or body, and since it is N-channel, it is P type. I told already, right? In body, we create drain and the source, heavily doped drain and the source region. So from here, we take source terminal, from here, drain terminal. So drain and the source are N plus region. And I told channel is available initially. This is channel. Here in between drain and source, we have oxide layer. Otherwise, I write simply oxide layer. Then we have metal. From that, we have taken gate. So it is metal oxide. This is semiconductor. That's why it is MOS we know. This oxide layer is acting as an insulator. It is a so gate current is 0, approximately I0. Okay, so how we are going to study this N-channel depletion MOSFET? How can we identify whether it is enhancement or depletion? So from this, channel is available initially. So from this, we can understand it is depletion MOSFET. Right, in enhancement MOSFET, channel is not available. That we will see in the next video. Okay, so I classified the operation into 4 different regions, right? So depending on the gate to source voltage and the drain to source voltage and the drain current. Because we know in MOSFET is a current voltage control device, so here output is drain current, which is a function of input voltage that we know. Right, this is all we know already. So depending on these parameters, how MOSFET works, let us see. So in case 1, what I do, I assume that VGS, gate to source voltage, is equal to 0 and VDS is equal to 0. So when VGS is equal to 0 and VDS is equal to 0, what will happen? I use this diagram. So when VGS is equal to 0, that means I didn't apply any potential or source, right? There is no source. If there is no source, that is, there is no source, then what will be the current flow through the device? There won't be any. There is no voltage, there is no current. So since there is no potential applied, since no potential, no current. So there is no potential, no current. That is no ID, right? No drain current. right? So I can call it as IDS, which is nothing but ID, which is equal to 0. Okay. Next we go to second condition. In second condition, what I am going to do in second condition, I keep VGS is equal to 0 and apply VDS. That is VDS is equal to positive voltage I apply. So what will happen? Let us see. When you apply VDS is equal to positive, here simply this is N plus P channel oxide. Next we have metal. Here we have source, gate and drain, right? So what I am going to do, here I am applying positive VDS. So when I apply positive VDS, what will happen, right? So you see it is N channel. So here the source is, there is a potential difference between what you call source and the drain. VDS is positive, so there is a potential difference. Because of this potential difference, what is happening here is electrons are attracted towards it, right? So electrons will start flow, right? So electron, this is positive VDS, so it must be positive, it must be negative, like that we can connect. So these electrons are attracted towards the terminal. So what will happen? The electron starts flowing, right? So the electron starts flowing. So charge carrier flows, which is nothing but current flow. So electron flows from source to drain region. That means conventional current flows in the opposite direction. So we call it as drain current. ID starts flowing, right? So this is the point we have to remember, right? So this current here, when you increase VDS, what will happen? ID also increases, right? So under what case? When VGS is equal to 0, when you increase VDS, ID also increases, right? So how long it will continue? Will it continue infinitely? No. It will continue till all electrons in channel contributes to the current flow. All electrons in channel contributes to current flow, right? Beyond that, even if we increase VDS, current flow will remain constant. That is, ID remains constant. So once all the electrons contribute, so even after if you increase, ID remains constant. So these are all happening under the condition that VGS must be equal to 0, right? Okay, so let me simply draw the curve like this, right? If you have a VDS ID curve, VDS ID, what is happening? Initially, if you increase VDS, ID will increase. Once all the electrons contribute to the current flow, then it will remain constant. This is happening when VGS equal to 0, right? So this is our case 2. Next we will go to the third condition, case 3. Here VGS is less than 0. That is, VGS is negative and VDS is greater than 0. That is, VDS is positive. Under this condition, what will happen? Fine. So under this condition, what will happen? Let me draw. This is right here, N plus region, P-type body, right? Here we have channel, here O, oxide, here metal, source terminal, drain terminal, gate terminal. Here what we are doing, here we are applying VGS is negative. So VGS is negative means it will be like this, let us assume. Right, so here what will happen? The negative charge carriers accumulate at the gate terminal. So here you see this is oxide layer, it is an insulator. Right, so insulator, via this we will have a electric field. The electric field pass through insulator, that we know. So since it is negative charge, what will happen? We know electric field will come towards the charge. That's what we have studied in EMS course, right? So for a negative charge, electric field lines will be like this. So field lines act like this in this direction. So that means what? So here in P-type substrate, we have positive charge carriers. When the electric field acts like this, what will happen? All the charge carriers comes towards this channel, right? So all the positive charges are attracted towards the channel region. So if you increase, because this force is acting towards the upside, up, it is acting upwards like this, because negative charge carrier is here, so electric field is here, right? For electrons, the electric field will be F is equal to minus QE, right? That we know. So force on the holes or positive charge carrier is F is equal to QE. So for positive charge carrier, electric field and the force will be in the same direction because F is equal to QE. So electric field in this direction, so force will also be in this direction for positive charge. So this force will move the charge carrier, positive charge carrier towards the channel, right? So what will happen? So electrons and holes will recombine. So electron hole recombination takes place. But initially, but if you increase VGS more in negative direction, if negative VGS increases, what will happen? More number of charge carriers will be attracted, and some of them will be recombined with the minority carrier, and they will start moving towards the channel, right? So this is what happens, right? So when you increase the negative VGS, recombination rate increases, right? This implies number of electrons will reduce because electrons are minority carriers, so in channel. So compared to body, electrons are minority here. So number of electrons decreases. This means what will happen? ID decreases, right? So number of carrier decreases means current will decrease. So if VD increases further, ultimately, let me take this is for small VGS. If you okay, so if my VGS is increased further, what will happen? At one point, it will become 0, right? So the value of VGS at which ID becomes 0 is called the pinch off voltage. This is very, very important point. So one other thing happen here is when you increase VGS and VDS, we know VDS is positive here. In this condition, VDS is positive. So here you see it is P-type, it is N-type. Here VDS is positive if you give, VDS means source is grounded. So VDS positive if you give, why I put a VDS here? Source is grounded. We know that. So source is grounded means S is 0, so I can put this is grounded. So this I can call it as VDS. If VDS is positive, you see the reverse bias is here. This is P, this is the N plus region. So reverse bias will happen because when you increase the VDS, initially reverse bias will happen. When you increase VDS, reverse bias will increase. So depletion region will form, and without the depletion region will increase. So what will happen? Channel starts decreasing in the N side. Right, so that is another important point. So when VDS increases, so width of the depletion region increases. Because of this, channel width reduces from drain side. Channel width reduces means resistance increases. Resistance increases means drain current start decreasing. Right? So when the entire channel vanishes, we can call that is a pinch off. When entire channel vanishes, what will happen to ID? There is no current flow. That is called pinch off. That is what pinch off. This is pinch off voltage. This condition is called pinch off. Right? So here what we are doing, when you increase negative EGS, ultimately what will happen? The channel will remove. We are removing the channel or depleting the channel. That's why it is called the depletion MOSFET. So by increasing, by applying or increasing, by applying and increasing minus VGS, what will happen? Channel is depleted, channel is removed or depleted. That's why it's called depletion MOSFET. Right? Initially channel was present. By applying this negative EGS, channel is, this is called depletion MOSFET. This is number case 3. Okay, next one is case 4. What we are going to do? In case 4, we make VGS is also positive. VGS positive and VDS is also positive. So under this condition, what will happen? Whatever happened in the earlier case, that will happen in the opposite direction. Let us see. Here you see N plus P channel oxide metal source drain gate. Here what we are doing, we are applying VGS is positive. VGS is positive means reduction values. Here positive charge carriers accumulate. So what will happen? They will induce negative charge carrier in the opposite direction. Already channel is made up of negative charge carrier. So here what will happen when you have a positive charge carrier? They will create electric field that will go away from that. Because we know for positive charge carrier, electric field will go away. So what will happen? We know F is equal to Q into E. So the force will also be in the same direction for positive carrier. So what will happen? Whatever the charge carrier is here, that will be pushed away. And for negative charge carrier, it will be opposite to the electric field. So all the negative charge carrier will be pushed in the opposite direction. So this region is added filled with more electrons. So what will happen? Here channel length increases. So if VDS is greater than 0, more electrons are attracted towards channel. Right? So initial recombination will take place as we did in the case 3. So minority carriers, then when you increase VDS more, they will overcome the recombination and go towards the channel region, because electric field in this direction, E is the electric field direction. For electrons, force will be in the opposite direction. So it will push electrons towards the channel. That's what F is equal to minus QE. Right? We studied Coulomb's law. So ultimately, more electrons will come here. So this means when VDS is greater than 0, I increases because channel width increases. So channel width increases means resistance of the channel decreases, simply current increases. That current is nothing but a drain current. Right? So this is what simply increases this, drain current increases, right? So this is the thing happening in the depletion MOSFET. So simply, if I want to conclude, we can make it simple. Case VGS, VDS, ID. Case 1, VGS 0 volt, 0 volt, ID 0 amps, right? So case 2, what will happen? VGS 0 volt, VDS positive, ID flows. When VDS is more, when increases, at one point ID remains constant. This is what we studied, right? In that case, what we studied, when VGS is negative and VDS is positive, what happened? So channel is ID start decreasing. At one point, channel is removed. This we studied. Okay, and the last case, what happened? When VGS is positive, VDS is also positive, what will happen? ID increases, right? So ID increases. Here, so this is the point. Here you see VD for VGS is equal to 0. For all VGS 0, negative or positive. But if VDS is there, what will happen? Current flows. Whether it is increasing or decreasing, that is different story. But current flows in both the positive and the negative direction of VGS. Another important confusion is whether VGS is positive or negative, ID flows. At one point it will become 0, but current flows. That is one important point we have to understand. When pinch off occurs, when VGS is equal to 0 volt and VDS increases, at what point ID become constant? That is called the pinch off. Right? So during the pinch off condition, VGS must be equal to 0. Clear? So this ID is the maximum drain current. Beyond that, it is remaining constant. Right? So why it is maximum drain current? Because you see, it is occurring at VGS 0. VGS 0 means short circuit. We know in short circuit there will be maximum current. Right? So if beyond that, even if VDS increases, it remains constant. That's what we have studied. So these are all the important points we have to remember. When channel starts depleted, this is conclusion 1, conclusion 2. Channel starts depleted when VGS is equal to negative, VDS is positive, right? Depletion occurs. So these are all the important 1 mark. Depletion occurs, right? So these are all things you must remember whenever you work with the depletion MOSFET. That's all about the class. If you have any doubt, please ask me in comment section. Thank you.